Hello everyone, my name is Sheng. I did my bachelor's in animal science at the University of Wisconsin-Madison, and now I'm a fourth-year PhD student in the animal welfare program. Today I will present a study on constructing a lameness hierarchy for dairy cows. Of course, every farmer wants to know which cows are lame and needs hoof trimming. We know that lameness is one of the biggest welfare concerns in dairy cows. It is highly prevalent, causing chronic pain and discomfort. The gold standard that we're using nowadays is a 4-level or 5-level gait scoring, which is far from ideal, because this is a very subjective and unreliable method. And this is exactly why we're proposing to construct a lameness hierarchy to rank the cows based on the degree of lameness instead, so that you can pick the top 3 or the top 5 most lame cows on your farm to check based on your time availability. First of all, I'd like to show some insights into why the traditional 5-level gait scoring method is not ideal. So we recorded 30 videos of cows walking and recruited 5 experienced lameness assessors, each scoring the same set of cows 3 rounds at different days. What we found is that when we asked different experts to score the same cows, they don't always agree with each other. Here, ICC measures the level of agreement among experts. So in the ideal world, we want ICC to be 1. So if perfection is at a 1 and we're only reaching 0.42, this is not good at all. In fact, even if we ask the same person to score the same cow at different time point, they don't even always agree with themselves. So as you can see, the traditional gait scoring is not very reliable. So can we do better than that? For those of you who were here in the previous IRC, I presented a foundational work on peer-wise lameness assessment, which is now published on Journal of Dairy Science. Our previous work has shown that asking people to assess which cow is more lame is a much easier and a more intuitive test than absolute gait scoring. Even people without an agricultural background recruited from the internet could reliably identify who is more lame when presented with 2 cows walking side by side. Based on this work, we converted peer-wise comparison results into a lameness hierarchy. For example, if cow A is more lame than B and B is more lame than C, then of course we would expect A to be also more lame than C. This hierarchy should allow us to accurately pinpoint the cows on a continuous spectrum from the most healthy to the most lame. So we generated 435 video pairs comparing everyone with everyone in the set of 30 cows. We invited 3 lameness experts to assess who is more lame and by how much more lame for each pair. We further constructed a lameness hierarchy using experts' peer-wise response, which put cows on a continuous lameness scale on the x-axis. Each of this hue distribution in this plot represents a unique cow. The further they are to the right, the more lame they are in this rank. And we color-coded each distribution of the cow using their ground truth average gait score from 15 rounds of gait scoring. The continuous color gradient from yellow to purple corresponds with average gait score from 2 to 4. For example, the dark purple hill to the right means that this cow has an average gait score of 3.9, and she is also ranked to be one of the most lame cows in the hierarchy we constructed. Here, we are trying to make sure that the lameness hierarchy constructed using our new method is still in high agreement with the average gait score. Again, if perfection is at 1, 0.79 is a pretty high agreement between this new method that we're proposing and the traditional gait scoring. On a side note, it took me 3 months to get all the experts to do all the peer-wise lameness comparisons to make this plot because experts are really busy. So the real question is, can I get the same lameness hierarchy from crowd workers from the internet who we can hire in a couple of seconds to do this task from the Amazon network? So we further recruited on average 18 crowd workers to assess each video pair. Asking them who is more lame, we presented with 2 cows walking side by side and constructed a lameness hierarchy based on their response. Here is a plot comparing the hierarchy generated from experts on the x-axis and those generated from crowd workers on the y-axis. Each eclipse represents a unique cow, and a bigger value on both the x and y-axis means that this cow is considered to be more lame. Remember that when ICC is 1, it means perfect agreement between experts and crowd workers. When we use traditional gait scoring, we were at 0.42. We were nowhere near perfection. However, now the agreement between experts and crowd workers from the internet is close to 0.9, which is really high. So in conclusion, we can accurately construct a lameness hierarchy of the cows based on peer-wise lameness assessments from crowd workers recruited from the internet, which unleashed the possibility of labeling large quantity of training data for automatic lameness assessment through the use of computer vision. Thank you so much for listening, and that's the end of my talk.